Good morning, everybody. I want to welcome everybody to KYTC Design Webinar. Today's webinar is going to be on InRoads Site Visibility, and it's going to be presented by Troy Woodyard. In today's webinar, he's going to show you how to access visibility tools, and he'll show you specifically how to use the Roadway Visibility and also the Surface Visibility tool, and kind of some of the advantages and disadvantages of using each of those tools and how they can work for your design. I want to also talk about some of the upcoming webinars that will be coming up. On Wednesday, March 4th, we will be doing intersection radius modeling, and it will be presented by Patrick Stone. And then on March 18th, we'll be talking about creating and detailing cross-sections. So that will, we're not sure who's going to present that yet, but that will be coming up on March 18th. And some other reminders for you all to note, all past webinars can be found on the KYTC design webpage. And if you get on our design page and look to the right of the page, you can click on software and support, and then the webinars are listed with the ability to be able to download and watch each of the webinars. And also, if anyone has any InRoads or MicroStation project-wise questions, you can send an email to KYTC space CADD space SUPPORT, and it is in the, for all the KYTC people, it's in the global. And that way, if you have any questions, you can just send an email to that, and we will get back with you as soon as we can. And I think we want to do a poll real quick. Let me get that going. Here we go. Well, okay. So here's a poll. Did you attend the previous highway design webinar? That will be a yes or no. Looks like we have about 85% coming in. So it looks like we had 81% that did attend the previous highway design webinar, and we have about 19% new people. So that's good. Okay, and we had one more poll question for you all. Let me... Have you ever used the InRoads Site Visibility tool? Yes or no? Okay, let's see the results of that. Okay, so it looks like most people have not used the InRoads Site Visibility tool. So Troy, it looks like you got your work cut out for you today. Are you about ready, Troy?
Yes, I am ready.
Okay. Chris, if you'll switch them over, we'll get started.
All right. So, like Wendy said, I'm going to be going over the site visibility tools in InRoads. So there's a couple different tools. There's the Roadway Visibility tool and the Site Visibility tool, and I'll just kind of run through what you need to have to be able to use those and what they're useful for, and then hopefully some pitfalls of things to avoid if you are going to use them. The first thing that you have to do is to load the Site Visibility tools, and mine are already loaded here under Evaluation. If you've never used them, they won't be there. What you have to do is go over here to Tools, Application Add-ins, and then if you scroll down to the S's, you'll see Site Visibility Add-in. You just toggle that on, and it tells you where it's going to put it, Evaluation, Site Visibility, and then these are the two menus that it's going to give you. So if you don't see it showing up here in Evaluation, you'll have to go to Tools, Application Add-ins to get it loaded. And then once you get it loaded, there's your two menus, and we'll start with taking a look at Roadway Visibility. And what this does, it's a three-dimensional site visibility analysis based on your DTM. So if your DTM is not good, then your information here will not be accurate. So that's the first thing you need, is a good proposed DTM, or if you're trying to analyze existing site distance, your existing DTM. The other thing you'll need loaded to run this one will be your horizontal alignment. So for our example here, we're using Kentucky 7 project in Elliott County that Jason did the model for. So I know the model is in good shape, and I'll just show you a small area of what the model looks like. And I've got it called, it's called Combined EXPR, and what that means is I have merged the existing survey data outside of my corridor with the proposed DTM data from the Roadway Designer into one surface, so that when I'm checking the site distance, it's checking inside the limits of the existing, or inside the limits of the proposed surface is checking that, and then when it gets outside of that, it's checking the existing ground. This is set up to where if you hit Control and click, you can select multiple surfaces, and it's going to grab, according to the help files, it's going to grab the elevation of the highest surface. That just kind of freaks me out a little bit. I want to make sure I know what I'm checking, and so I suggest just combining the proposed and existing into one surface. So just go ahead and just look at the triangles inside this little area to so I can show you what it looks like. But the reason why that you're going to want to make sure that you're not just using a proposed is if you're trying to check site distance, for example, from this, you wouldn't check it this far probably, but from here to there, you can see my cut ends right here. And so you're going to be shooting across the exterior boundary of your proposed surface. And these tools really just freak out when you start crossing the boundaries. So this is the intersection that we're going to be looking at in a few minutes, but right now we're just looking at the corridor. So you can see, you know, we've got the cut model here and the fill, and then when you get outside of the corridor, you've got the survey data. So that's what, when I'm talking about a merged surface, that's what you need it to look like. If you don't know how to create that, a couple of months ago we did a webinar on how to merge proposed and existing surfaces, so you can check that out on the website. So anyway, I'll go through what these different menus do on the Roadway Visibility tab. So the first thing you're going to check is under the General tab. Well, I'll go ahead and these are preferences that you can set up, and I've set them up to save it. And all these do is specify the line styles on this last tab. So first in the General, you want to select your surfaces. So I just want to select this combined surface. And then you want to give it a horizontal alignment, which this is my horizontal alignment that I'm using. And then you have to give it a start station, a stop station. So if you want to analyze the whole corridor, you can just start it down there and stop it up there. You notice the reverse. If you hit that, it switches the order. And that's important because it's checking from start to stop. So this run, when I hit apply, it's going to check it from here to there. So it's going to start here and look ahead my sight distance, and start there and look ahead my sight distance. So if you want to check it coming the other direction, you'll have to reverse it. You can check it however often you want due to processing time. I'm going to change my interval to 100 feet for the webinar. You could check it more or less often depending on what your purposes were. This sight distance and relaxed sight distance is a little bit tricky. I recommend that you just make both of them the same. So in this case, I'm going to use 495 because I think that's the 55 mile an hour sight distance. You can find that in the Green Book if you don't know it. But what it's going to do, in this tool, it's not checking. When I tell it 495 feet, it's not going to check from this station to 495 feet ahead along the station and check every point in between and see if it can see. All it's going to do is start at whichever point it originates at, and it's going to draw an arc, and the arc is going to be 495 feet long. So, or sorry, not an arc, a chord. The chord will be the sight distance. So the arc length will be a little bit longer than the chord. So it gets a little bit imprecise, which is probably not a huge deal because the arc length is always going to be longer than the chord, so you're actually going to be being a little bit more conservative. So this is going to set a chord of 495 feet. Now what the relaxed sight distance does is if I was to make it, let's say, I don't know how far that is, let's say that's 495 feet, and if I was to make the relaxed distance 200 feet, what it's not going to do is make a chord 200 feet like that and check both of them. What it's going to do is it's going to check 200 feet along this 495 foot long chord and see if you can see that distance. So in my mind, the relaxed sight distance is a little bit useless. What you might be tempted to do is to say, I want to see everywhere I can see 1,000 feet ahead, but really my sight distance is only 495, so I'll make that my relaxed sight distance, and I'll see everywhere I've got more and then where I've got the minimum. But what that's going to do is change the direction of your chord to something out here that you don't want, and it's going to check 495 feet along that line. So I hope that makes sense as to how it's working. And also to make note, it's it's going to be checking something greater than 495 feet when it's in a curve. So it might not be a huge deal. If it tells you it fails, it might barely fail, and you might want to investigate more in depth to make sure that you don't have like 498 feet of sight distance and it's telling you it fails because of the chord length and arc length issue. And the last thing I want to mention about how it works before we keep going through these tabs is it's not going to check every sight distance from here to 495 feet. It's only going to check this one sight distance. So if you have some very small dip or some sort of geometric anomaly or something that happens in between this point and that point, it's not going to analyze that. So just because it meets at 495 doesn't mean it's going to meet at 400. So I say that just, most of the time that's not going to be an issue, but just by way of warning, don't type in your required sight distance and hit go, and if everything turns green, just accept it as gospel. You're going to have to do some more investigation and make sure that it's giving you the information that you want it to. You can turn on this Create XML Report box, and that's going to give you a readout, which we can look at when we run it in an XML version. If we go here to the Positions tab, Eye Position and Object Position, it's going to be telling you the X and Y locations that it's analyzing. So here we're telling it we want to get the X and Y location from the active alignment, and I'm going to offset it 6 feet because I've got 12-foot lanes and I want to measure to the center of my driving lane. The eye height, no matter whether you have geometry or surface, the eye height is going to come from your DTM. So if you were to pick surface, it would allow you to select a feature instead of an alignment. And so you could check sight distance along a surface feature, but I don't know exactly why you would do that. So we're going to do the alignment. And then the eye height comes from the Green Book. You can look it up there, but it's 3.5 feet. And then we're going to do the same thing on the object, and the object height is 2 feet. And we'll turn on our offset on that too. And then, if you think about it, when you reverse it, you're going to want to be checking the other side. And if you'll notice, I went to General, hit Reverse, and now I've got -6 because I'm coming back the other direction. So it makes that switch for you. So now I'm going to go back to where I'm going, ahead station, and check in on the right side. And then lastly, this is just how it shows up. These are the graphics that'll show up when you run it. So I'll just go ahead and apply it, and we can look at the graphics together. At the beginning of each line, there is an originator, is what it's called, and then the line itself is called desired, relaxed, or unacceptable. And then at the end of each line is called a terminator. And so you can set this up if you just double click on them. You can set it up with any symbology. If you want it to be red for failing and green for passing, that's generally what I like to see. You can do that. If you just want to see the lines and not the terminators and originators, you can turn all that stuff off. And now that stuff goes away. So this works just like your other InRoads preferences. And so you could go to Preferences and save it. I've got one set up with just the originators, but I don't want to lose all. It'll clear out all your default values here, so I don't want to load it. But if you just wanted to see the originator, you could turn all those on and hit Apply. And now it's going to give you a green plus everywhere. So from this point ahead 495 feet, you've got sight distance. And then I think there's a couple maybe at the tie-in at the end of the job that it looks like they all pass. So so you can stylize it any way you want to see it, and then you can save it as a preference so that every time you do it, you can just load that, and you won't have to go through that every time. And then this sight length line, I'll go ahead and show you that. I don't know why you would ever change it to actual distance. The way I understand it is what it does is it shoots off your line, like it calculates your sight distance the same way that it does under here. The only thing you're changing is the line length. And so what it's going to do is, instead of stopping the line wherever it meets the 495 foot that you've prescribed, it's just going to shoot it off the same direction until it hits the edge of the surface. So I suppose if you wanted to know whether or not you could see over a fill or something, you could turn that on. I'm not really sure that that would be that useful. I don't use it, but that's what that does. And then it'll come up with your XML report. Easy for me to say. There it is. And so it's just going to go every point that it calculates. It's going to tell you where it put the eye, that station, that offset, where it put the object, and if there's an obstruction between the eye and the object, where it was and what elevation it was at. And then, it gets down here to where there's no obstruction. And so, I don't know. I don't use this Roadway Visibility tool terribly often, but it's easy to run. So if you want to do a check, or if you've got somebody concerned with site distance on your project and you want to create a display showing where your deficiencies are or something like that, you could use this tool for that. So that's sort of how you use that. If you've got any questions, you can go ahead and start sending them in, and we'll maybe just come back to all of them at the end. I'm going to move on now to the surface visibility tools. And what these need, these don't need a ALG file at all. This is all strictly gotten from your DTM. The same warnings apply. If your DTM is not accurate, your visibility calculations won't be accurate either. And these are also very sensitive to crossing a surface boundary. I've found some issues where, like, if the sight line is shooting underneath of a disconnected surface or something, it freaks it out. So just be careful that you've got coverage for the whole area that you're trying to analyze, and that you've got one continuous surface that you're using. So the first thing that I want to mention on surface visibility is the layout is a little funny. You've got 4 tabs, and the general tab, there's 3 different modes of analysis here. There's surface points, surface regions, line of sight. If you'll notice, those are the tabs on the left side here. Each of these 3 analysis types uses the general tab to set the eye position, and then it uses these other 3 tabs to set what you're actually analyzing. So if you want to run a surface points analysis, you need to fill out the general tab and the surface points tab. If you want to run a surface regions analysis, it doesn't matter what site radius you have in the surface points, because you're running a surface region, so it's going to get the site radius from the surface regions tab. It makes sense after you know what it's doing, but if you don't know what's going on, you might wonder why you're changing stuff and it's not seeming to work. So on the general tab, I'm going to set up the same surface here. This is my combined proposed and existing surface. And the mode, we'll just go through them one at a time, and I'll show you what they're doing. So I'm going to start with surface points. And then for the eye position, I am going to put it right here. I'm going to check the intersection sight distance on this entrance. So I'm just going to put it in the middle of the entrance. If you were on an approach, you might want to put it in the middle of the driving lane that you're trying to analyze for. Chapter 9 of the Green Book has explanation of intersection sight distance. I'm using 14.5 feet off the edge of traveled way. I think it recommends 14.5 to 18, with 18 desirable or something like that. But you can look up all the specifics for your case, because there's different cases for if you're turning right or left, or whether it's signalized or unsignalized or stop controlled. So consult your Green Book for the engineering. I'm just going to attempt to show you how this tool actually works. But I'm going to put my eye, if I just use this little picker here, snap to there, that's where my eye is, and it comes up with this little circle. Now for the elevation, I have drape surface on there. So what it's doing is it's going to this northing and easting on this surface, and it's pulling the elevation off the DTM. If you don't have your entrance or your approach in the DTM that you're using, then what you could do is take the drape surface off and come in here and calculate off your entrance profile whatever elevation you have at this point, type it in there. So if you need to analyze the entrance side distance on an entrance that you don't have in your DTM, that's how you can get around that. Now the eye height is still 3.5 feet here, and once again it's in the Green Book if you want to reference that. So we'll go to the Surface Points tab, because that's the analysis we're doing. Let me see if I've got any preferences. I'm going to go ahead and load these just in the interest of time. I've already got the colors set up the way I like them, with the green and the red. So What you can do, though, if you don't have that set up, you can just double-click on it and assign it whatever symbol you want, whatever line style, whatever color you want. So that reset my first screen when I loaded that. I should have done it first, but okay, everything appears to still be set up after I reloaded that point. So all that did was set up my colors for me when I loaded the preference. But my object height on intersection sight distance is 3.5 feet instead of 2. So you can, once again, consult your green book on that. I'm going to check a sight radius of 495 feet. It's also important to note here, it's going to check a 495-foot radius from this point that I specify. It's not going to start at this station. It doesn't know what this station is. It's only using the DTM. It's not going to start here and go 495 feet with the road and check to there. So what you may have to do is increase your sight radius to, you may have to calculate this station and the station you need to be able to see to and put a little construction line there and then increase your sight radius until you hit that to see if you can see that far. But that's only 2 options. If you hit apply, it's going to check sight to every vertex on the surface that's within that radius. I hope that's what it's going to do. Oh, I had this preview of surface regions. When I loaded my preference, I changed it from surface points to surface regions when I loaded my preference. So that's why the processing time took a little longer. So let's run that again now that I've got it hopefully set up right. So it puts a plus at every point on the surface within that radius that I can see. And these are all vertexes of the triangles, I believe. And then if it can't see the point, then it puts a red one. So you could say if this is the distance you're trying to check, you're green the whole way. So you can take that and show somebody, you know, we can see here. This is good. We'll go on to the surface regions, which is the one I showed you on accident. What this is going to do, it's going to shoot out those lines that you saw radially from the eye position. And so if it's set up at 1 degree, it's going to show you 360 lines. It's kind of a lot. You can set it up at 10 degrees. You can set it up by number of radials if you know you want 20 radials or something. You can set it up like that too, but we'll just do every 10 degrees. Object height stays the same. You'll have to change it here if you want something different. And then the sight radius, we'll just leave that there. So we'll run it again. It shouldn't take us long now that we're not doing quite as many. And I forgot to change it again. So good demonstration of why this menu is a little confusing sometimes. So I changed go back to the General tab, change it to Surface Regions. Now we should be good. So there you can see we got the same results basically. You know, everywhere along the road it appears to be green. You could densify these a lot. I mean, you could do every half degree if you wanted to really see. But what these are doing is draping these lines along the surface. So if we go to a 3D view, these sight lines are draped along the surface. So you can see that that kind of looks like what the surface looks like. And every point, I think it skips some points if they're within a couple hundredths of the next point. But just to show you what it's doing, well, let's look at our triangles again. Every point this line crosses a triangle, it's dropping a vertex. And it's checking every one of those points to see if it can see it. from this point. And then I think it's doing some sort of interpolation when it gets to an area that's where it can't see anymore and it's going red instead of starting at the triangle edge. I think it's doing some fancy math to determine how far along that triangle you can see. So anyway, this is the one that I use most of the time when I'm trying to do a site distance analysis. I don't use the regions or the line of sight very often, but we'll move on to the points or the line of sight very often. I use the regions. We'll move on to the line of sight. And one thing I want you to see, let me get rid of some of this stuff so it's not as confusing. If you look here for the symbology, this says visible, not visible, visible, not visible. When you go to line of sight, it says above ground or below ground. So what this is going to do is it's going to check and see if you can see above the ground or below the ground. What it's not going to do, maybe it would be best if I just showed it to you. There's a line of sight. I think I've got it in here still. I'm going to check to this point. So for my object, I'm going to set it right here. And I'm getting the elevation from my surface again. And I hit the wrong thing. So I have to wait till it finishes. I didn't change it to line of sight on the General tab. So this gives me a line of sight out to this point, and it tells me green means it's above the surface. So that means I can see it, right? Well, probably not. If we cut a profile along there, we'll just do a multi-point alignment. Hopefully this will show you why I'm a little leery of this tool. Let me turn off the grid lines here so we can see this. Whoops. Good enough. So what this is doing is it's starting at this point, it's going up 3.5 feet and drawing my little stick guy, and then same thing on the other end. Close that, and then it's going to connect them with a line. And common sense would tell you that once you get past this point, you can't see anything. So why am I seeing green? Well, technically, this line of sight between that point and that point is above the surface right here. So that's why that's not specified as visible and invisible, but whether or not it's above the surface. So we've got green, red, little bitty green, red, and green, which corresponds to green, red below the ground, little bitty green above the ground, which you still can't see because of that, red, and then green. So that's what the line of sight tool is. I don't really find that one that useful, but that's how it works. Just two other things that I think this is useful for. I'll show you. We've got another job attached here. This is something that Patrick Stone did in our section, and let me see if I can open this other drawing and show you. Oh, whoops. I think I just opened a bunch of stuff. We'll see if it works. This is a little presentation he did. I'm not sure if it was for a public meeting or just for documentation purposes, but I thought it was cool. So And he used the surface regions to develop this. It's a display. I mean, this might be something that you would use in a meeting to get your point across, or if the public is concerned about it. But he looked at the existing and proposed conditions. This bridge didn't have guardrail on it, and we're proposing to put guardrail on it. People are worried if we put guardrail on it, we're not going to be able to see. And so he just did multiple cases, one for each of the entrances, showing what regions, using the surface regions, what regions you can see and what regions you can't see from each of the 4 or 5 entrances on this job. So I thought that was a cool display, a way that you can use this tool. But I want to show you how you do that. And if you look at the surface, he's got a point that's the height of the guardrail. So there's multiple ways you can do this. If you have your guardrail component in your template, you can just, it's usually set up to do not triangulate. So you can change that to a triangulating feature. If you don't have it in there, then you can drape a line or offset a line up. But there are multiple ways you can get there, but you need to have a line that's the height of the guardrail and the location of the guardrail. And so you can see it doesn't look like guardrail or anything, but it's a triangle that's the correct height. And then so we can just do the same analysis here. If we change it to surface regions, and we'll put our change our surface. This is, I think, the surface we're using. Put our eye right here where the car would be sitting before we pulled out. And that's all set up, so we'll see if that works. And so you can see area, you know, just to the right of, I think this is my crosshair where I have the station set up, but you can see the screen line here where it's checking as it goes up the guardrail and back down. And so this is the first point obstructed along that line by the guardrail. So that's something handy that you might want to check on bridge ends or something like that. And then another thing that somebody brought to my attention, they've been having some sight distance issues in their district with situations where at an intersection where it technically meets the sight distance, like you can see the prescribed distance ahead an object that's 2 feet tall, but you can't actually see the roadway, and so it kind of was freaking drivers out. So one thing you could do to check for that, not saying you need to or have to design for that condition, but it might be good information to have, is if in the roadway visibility under positions, you could set your object height to 0 and see. So I'm not looking for an object in the road, but I'm actually looking for the road to see how far ahead can I see that there's actually pavement there, and that there's not a car coming, basically. So I don't know. Those are a few. That's pretty much all I have, I guess. I just want to give some warnings that make sure that your DTMs are good. Make sure you know what these tools are doing so that you're not doing a line of sight calculation and it's telling you that it's above the surface, but you're not really able to see it. So I guess that's all I've got at this point. I don't know if we have any questions.
Troy, we do have a couple questions. Can you see them on your screen? You want me to read them to you?
Yeah, I think I can see them, but I've only got like one. There we go. Let me read these.
Okay.
Okay, the first question, do you have to be in the 3D DGM for site visibility to work, or can it be done in the 2D also? I haven't actually tried it in a 2D DGM file. I would assume that it works because the data that it's pulling is from the DTM and from the ALG, but I don't know that to be true because I usually default to working in a 3D file, so I didn't check it. We can check that and let you know. It may freak it out because it's actually drawing the lines at elevation. So I don't really know, but I think it would work. The other question was about guardrail, but I think that came in before I showed that. So
Yes, it did.
and someone is saying that they have used it in 2D file and it works fine. So I don't know if anybody has any other questions.
Last chance for anybody with any questions. I don't see anything coming in, Troy. Oh, wait. Oh, just a thank you.
You're welcome.
All right, Troy, if you don't have anything else, I guess
That's it.
that calls it a webinar.
All
Great
right.
job.
Thanks.
All right, thank you all. Have a great day.